So let's look at tabular processing of our model. All processing starts in the project for a tabular model of analysis services. The processing here is done in the workspace database in order for data to be previewed while developing. There are a couple of options for processing, and the first one is for partitions, which is usually just associated with a fact table where we divide things by, say, the year. The next one is for table, which means you can process either one or more tables based on if structure or data has changed. And the other one, all, means to process the entire structure and data of this tabular model. To process to a server instance instead of the workspace database, an analysis services database will be created on this instance. You have to deploy by right-clicking on the project or going to the project menu choice and deploy for the tabular model all its structure and database to be processed to an instance. When it is finished, you get a message like the window on the screen that shows what was transferred to this instance. In order to script this processing out, you have to use SQL Server Management Studio to either individually process tables or the whole database. The script is XMLA, which is the Analysis Services Markup Language. This language actually changes in the new version of SQL Server 2016. When scripting, you will be given options for the different modes of scripting. Here you can see a list of the default, full, data, clear, and defrag, along as a list of the tables. Full is structure and data of the selected tables, whereas clear would remove the existing data, data would process that removed data, and then defrag will help structure and complete the indexes. When scripting, you can mix the processing with different tables as seen here. So here you can see a process full on the database, whereas the date and the internet sales is by data. You use the default for product and the default for category. The next thing is to get this script and put it into a job to be scheduled to run. Once you have this script, you can use SQL Server Agent to create the new job. You click the new job from SQL Server Management Studio under SQL Server Agent job and give it a new name, like Process Tabular Module. You add a step where you place the script, and you can individually run each table and the measures that were created. You also have to select type as an analysis services command in order for it to be run against an analysis services database, and then provide the server. In this case, we put in the period for local instance. Lastly, you want to schedule a date and time. In this example, we're creating a schedule for nightly that runs daily at 11 p.m. every day of the week. Next, we'll look at the processing options for a tabular model. We're going to launch the SQL Server Data Tools and open up our tabular project. Once we have our project open, we're going to go to the menu choice for the particular model that we are working with. This model will be able to be processed on an all level for all partitions as well as individual ones. If we go to Model and to Process, we'll see Process Partitions. Here we have a default, a full, and a clear and recalculate. All these options are available, and usually full is the best one to do. When we click OK, we'll see the processing. Now what's happening here is that this is happening within our workspace database. If we wanted it processed to our deployed server, we right click and go to Properties, and we see that this is going to be deployed to this instance and this database. In order for that to happen, we have to right click and click Deploy. Usually you use this option just when you're initially deploying your cube to a different server other than your workspace. After that's been done, now we'll go into Management Studio. We'll launch SQL Server Management Studio. Once it's launched, we're going to connect to the tabular instance of our server. And then we're going to drill into the database that we want to have processed. Here we'll right click that database and go to the process database option. Now this is going to process the entire database, and we could script this out if we wanted. We have process default, which actually does only the changes inside of the database. We can also process individual tables. So if we drill in to the tables, we can right click on product and click process table. Here we could choose which scripting mode we want to use and say we want to do a full on our product, category, and subcategory. Then we could just script those out to a window. If we wanted a default for, say, date, then we could still do that in the same options here and script it out. The last thing we need before we actually create a job is the actual cube, which is the internet sales. So if we go to internet sales and look at our partitions, we see we only have one partition. So we can right click and process this table and do a full on this particular table. So now we have some individual dimensions as well as fact processing. So we can go to the Object Explorer, connect to our Analysis Services database engine, go to SQL Server Agent, and right click on Jobs. We'll create a new job called Process Tabular, and we'll change the owner. Next we'll create the steps. The first one we'll call Process Product. And here we'll go get that script which has the category, subcategory, and product. We actually need to process these in a particular order, which I'll change once we put it into the job. Because first you're going to need to process the category, then the subcategory, and then the actual product dimension. So they need to go in that particular order based on the data. We'll click OK, and we'll create a new step for processing the date. And again, we need to change the type to Analysis Services Command, pick our server, and go grab our script and paste it in there. I did make a mistake on the process the product by not changing the type to Analysis Services Command and specifying a server. The last step is going to be to process the fact table. Here we'll copy the script, create a new step, and say process internet sales. And if you notice, we're processing the product and the date and then the actual fact table. You need to do it this order in case new data has been added to your database. That is the whole reason we would script this information out to be processed in a job. In the Advanced tab of a new step, you could change the on success action as well as on failure, and even tell it to retry a couple times. You could also output the commands or the log information to a text file to be reviewed later. The last thing we need to do is create a schedule. We're going to call it the Nightly Tabular. We'll do it daily at 11 p.m. When creating a schedule, you can specify the type, which is a one-time occurrence. You can enable or disable the particular job schedule, and you can tell it how the frequency is, daily, weekly, or monthly. So say, for instance, we just wanted this on Sunday, Monday, Tuesday, Wednesday, and Thursday, and we want a different type of processing on the weekend for Friday night or Saturday night. We could do that here. When we click OK and click OK, we'll go to the Project Explorer and notice here that that new job is scheduled to be run. When we scroll to the right, the next run is going to be tonight at 11 p.m. Backups is our next topic in the additional options of analysis services. Backups are the same for both the multidimensional cube and tabular model. You have to execute in SQL Server Management Studio. Restoring a backup can happen on the same instance or a different instance. Restoring a backup can be used as a deployment method. This actually may be faster than processing because you can offload the processing and backup on a different server, then restore to a development, QA, or production environment. The best practice is to back up on a regular basis. If the data is processed nightly, then back up nightly. If weekly processing, then backup weekly. A backup is only as good as the restore, so practice restoring the backups to make sure the backup is good. A good practice is to restore to a development or QA environment of a nightly or weekly backup. Always remember, you can reverse engineer the deployed analysis services database back into SQL Server Data Tools as a project. The backup script can be used in a SQL Server agent job to schedule the occurrence of the backup. The relational database or source file should be backed up just as often, if not more often, than the analysis services database. If you have SSAS packages to deploy or process the analysis services database, those ETL objects through SSIS need the same backups as the deployed solution. The best option for the solution or project and SSIS packages is to use a source control tool like Team Foundation Server or TFS. The source control system needs regular backups as well. If any encryption is used in the database or the backups, those keys need to be documented and available if a restore is required. There's also the MSDB database in the database engine. This is a system database. This database needs to be backed up in order to store the SQL Server agent jobs. System databases like MSDB should be part of a regular backup strategy. You can also script jobs from SQL Server Agent and have those text files of the scripted job saved to a backup area where an agent is picked that up by some system administrator. Next, we'll look at backing up the analysis services multidimensional and tabular cubes. First, we'll launch SQL Server Management Studio. Once we launch that, we're going to connect to the analysis services multidimensional cube instance. Here, we'll drill into the databases and right-click the database that we want to back up. We'll click the menu choice Backup, and we're given a set of options. The first is the database, and the second is the file. We can click the Browse button to change either the path or the file name for that database. You'll notice it gives it an ABF extension. The other things we are allowed to do is overwrite the previous file, apply compression, and encrypt the backup file with a password. If you want to protect the backup, you can put a password on this backup file, and only a person with access to that password will be able to restore it. The Allow File Overwrite lets us schedule this on a daily basis, and it overwrites the previous backup. If you don't want to overwrite it, then you'll need to create a script that can uniquely name the database file on a scheduled basis. We'll keep these options and click the script button. We'll cancel this and look at our script. It's a very simple XML file. We can copy this, go to our Object Explorer, and connect to our database instance. Here we can go to SQL Server Agent, right-click on Jobs, and create a new job. We'll back up the cube, change the owner, and create a new step. The step will be Backup Cube. It is a SQL Server Analysis Services command, so you have to specify the server and paste the text. We could click on it and actually create a file somewhere on disk to log this. Tell it to append the output, not to overwrite the output, and click OK. We'll go back to our Management Studio, go to the Object Explorer, and connect to the Tabular instance. Here we can do the same thing. Right-click the database, select Backup, and we're given the same options. We'll allow overwrite, but we'll apply the compression, and we'll script it out. We'll copy the script and go back to our job and create a new job. We'll say Backup Tabular, change the type to Analysis Service Command and then specify the tabular instance. We'll paste this, go to Advanced, and use that same backup file as our log file. We'll append and click OK, and if you notice, the on success will go to the next step. Here, the second one needs to complete and say quit job and report success. The last thing we'll do is create a schedule. We'll say nightly, backup. It's recurring, not a one-time. It'll be enabled on a daily basis. And here, we'll do this at 11:30 p.m. Now you want to schedule this either before or after your processing. It depends on what your SLA, your service level agreement, is with your business. You click OK and OK again, and now we have a scheduled job. If we go to our job activity monitor, we should see backup cube. We can start the job and let it run. We might get an error here, but we'll see what happens. And yes, we do. We'll close that, right click, and go to view history, and we'll see that our job failed. It'll give us details, and what it's telling us is here it's unable to open up that setup file. I'll close this, go back to the job, go to my step, and we'll take out the logging of the data. We'll do that for the second step as well. And close the job. Now let's see if we get a complete backup. As it's processing, it's going to create those files to disk, and if it doesn't, we right click again, view history, and look at why it failed. We have the first one succeeded, so we do have a backup of our cube, but we don't have for the second one, which is our tabular module. And here it's giving us a message that our SQL Server agent doesn't have permissions. I'm going to copy that particular login, and I'm going to go to my tabular instance, to properties, and go to security. And here I need to add that particular login. Now it should have access. Also, when I right click to start the job, I don't have to do it at step 1. Now I can do it at step 2 and see if we get a successful backup. And we do. In this next section of Analysis Services Additional Options, we're going to look at optimization techniques. Optimization comes not just from queries. You have to look at all parts involved in this solution to find all available performance gains. So remember, it's not just the database and it's not just the cube. You need to look at all areas. Once in production and you've deployed your first Analysis Services database, you want to create a baseline based on the process time, the volume of new data, report response times for your end users. You want to track this on either a weekly, monthly, or bi-monthly basis, but have a baseline in the beginning to compare the difference in the performance. Remember, this is an ongoing process and cannot just be set and done. Like any application that is a hit, more and more people are going to want to use it. Those new people and the existing ones, once they get comfortable and are impressed by what it does, will start to request new items. And then there's going to be a continuous push of the reporting, which will be constant. So once someone sees something that runs nicely, more and more people will try to push it to see if it'll hit a limit of performance. The first step, and is what we talked about in the first 2 sections of this whole module, is good dimensional modeling. Looking into better techniques for dimensional modeling will always help with performance. The Kimball Group uses a nice step-by-step about finding the grain and the dimensions, as well as designing surrogate keys and slowly changing information to help you make changes to an existing structure. This foundation is as important as the end product, so don't skip on this And remember, if you have a fact table and dimensions that is performing well and they request something similar but might be something that additional measures are available for, don't be afraid to create a new fact, new ETL to populate that dimension. Learning about conformed dimensions will help you bring these fact tables and measures together in a cube. Clean the data in your ETL. When you clean the data in the ETL side, it is much better for performance than trying to do it in a view or data source view. Getting it done in code will catch other problems as well. So please figure out it at the data and ETL level. If things don't match what the end user is requesting, put that data aside, maybe ETL it to a staging area, and review it with your end users. It is better to get their decisions on how to move forward with dirty data or incomplete data than it is to assume that you might know what they want. Using views to combine data from multiple sources for a dimension or fact will eventually show its ugly head in performance of reporting and processing. Always go back to the table design with new attributes or measures if those are requested. If you followed the Kimball dimensional modeling, it is not going to be difficult to add these to the existing structure. If you see you starting to create more and more calculated columns, then that is a flag to go back to the table design. There's big debates about nulls, but in the dimensional modeling, you should not allow nulls. This will help with the customization in an analysis services database. Replacing these values, nulls, with something like NA or not available descriptions, rather than having the unknown property pop up in a multidimensional cube, or using logic and columns in a tabular model, does not bode well for the performance of an analysis services database. You will be thankful for taking this tack in design and import of data through your ETL. Get with your end users if NA is not an option and find out what can best be done in the source data so they will be satisfied with your results. Query performance is usually one topic that's talked about more and more on the database and cube side, as well as tabular. The multidimensional cube has something called the usage optimization option. This is used on a system level to track MDX queries that are running from your reports against your cube. Later, this capture of MDX queries can be placed in the aggregation generator, and this we described in earlier modules. These aggregations are actually your indexes for measure groups and dimensions. A full process of a cube once a month or so can help with the indexing in the cube when more and more data is added. If you have a break sometime in the week or month where there's nobody using and the time process of the whole cube is not a problem, please implement this. Don't be afraid to schedule this process like sometimes during the maintenance windows that the DBAs might be familiar with. Always remember to create just what was requested from the end user rather than trying to add everything at once. I did this when I first started designing cubes and noticed that more and more information in a cube confuses end users. If you can scale it down to just a few measures and dimension attributes, your end users were more likely to use this cube. If more and more smaller changes are requested, sit down with the business group and try to hash out more requirements during the initial development of new modules. Try to determine how these smaller and smaller changes can be compacted into one big push to production rather than a bunch of small ones. And there's no need for everything inside the cube. Remember, everything makes it confusing to an end user. And the last thing we'll talk about is monitoring. Monitoring can be done with the system-level perfmon application or profiler. Perfmon is good to track the individual CPU, memory, and disk I/O. Separately, any service that runs inside of Windows will have individual service-related metrics. You can gather these just like you do a baseline of what maybe the query time returned to end users, and store this in a database. And as you collect it over time during peak hours, remember sometimes there's nothing going on in a cube. You want to eliminate that in the average. Profiler is currently being replaced with something called extended events, but it's good to get your feet wet with Profiler first before moving on to extended events. Because once you understand what Profiler can do, then you'll scale that down to only the things needed to monitor an analysis services database. So don't hesitate to learn some new things like extended events.